Geotrig, lesson 5, day 5, last concept of the lesson. So, today we're going to actually talk about the diagonals of solid, generally prisms or boxes. I think everybody would understand that if you had a box like this, the quickest way from, say, point B to point H, which is, if you can see that B is in the front left corner, that H is in the back right corner. The quickest way to get there is following this dotted line, which would actually have to go through the box. So to go through the box would be the shortest distance. But what is that distance? Notice that I do not have numbers on my box. I have X, I have Y, and I have Z. I think everybody should recognize that if this front face from B to C is X, then from F to G is also X. Also from A to D is X, right? Those parallel sides, or the sides that are the same length, are all the same value of X. Just like if this height is Z, then this height is Z back here, up front, and over here, the back. Right? So when we're talking about a box, there are things that are identical length around certain areas. You got to the same height all the way through, the same depth all the way through. So Y goes backwards here, Y goes from D to H here, A to E over here, and B to F. Those are all Y's. But what is the distance then, using X, Y, and Z, from B to H? We got to figure this out. Now, if this is a box, what can you assume at every single corner? 90-degree angles. So, everything in here is going to be full of 90-degree triangles or rectangles and so forth. I got a question. This box on the bottom, could you tell me, or could we find, the distance from B to G?
Yes. Yeah.
Do you see that from B to G, it is a rectangle? And that rectangle would have a 90-degree at the corner. Can you guys see that? So if I had to, I could break it out here. This would be B, C, and G. That's across the bottom looking from the top of the box. Can you see that? But it's laying down. B to C is how big? How big is B to C? They're calling it X. What about from C to G?
Why?
Do you have enough information knowing that that's a right angle? Could you find the distance from B to G?
Yeah.
Using what formula? Oh. Pythagorean theorem, correct. So, A squared plus B squared equals C squared. What's A? A is one of your legs. Which one? Where are your legs?
Below my waist.
The legs would be either X or Y. So let's call it X is A. B would be then the Y. Equals, I don't have a variable for that, but can I just call it BG squared? Is that okay? Because that's distance BG. Line segment BG squared, the distance. So wait a minute, that's X squared plus Y squared equals BG squared. Probably should take the line segment off of that because it's really talking about the distance, which is BG. So when you have the segment, just nothing above it, that means signifies its magnitude or its distance. So we got BG. So how do I solve for BG then? How do I get BG by itself? Not divide. I can't divide. I can't divide to get rid of squares. Take the square root, right? So if I take the square root and square root, that means square root of x squared plus y squared equals BG. So guess what? This length is x squared plus y squared square root. Or the square root of it, right? So guess what? That is also what I have to put in here. Notice that I put that on that red line that goes across the bottom. Wait a minute, guys. Look at this object again. If I go from B to G, how do I get to H? Go straight up. What is that height? It's Z. So, we know that's Z. Wait, isn't that also a right triangle?
Yeah.
Isn't that just this? With the Z on the top, on the side, and the bottom is the red diagonal line, which was x squared plus y squared? Can't I find BH by doing Pythagorean theorem again? I need some room, so I'm going to erase this work now. But I'm going to definitely use a squared plus b squared equals c squared. Oops. Get rid of this. So, in this case now, it's a new triangle, right? What is A? What's one of your sides? What's one of your sides? Huh? Z. So then what's the other side? Almost. It's the square root of x squared plus y squared is the other leg, right? This will equal the length BH squared. So what's Z squared? Z squared is Z squared, yeah? What happens with the square root of x squared plus y squared squared? What's going to happen? What's going to happen with the square and the square root? They cancel. So you end up with x squared plus y squared equals BH squared. But to get BH squared to itself, or by itself, you need to take the square root again. So guess what? BH equals the square root of, I'm going to put them in order, x squared plus y squared plus z squared. Hey, wait a minute. Doesn't that look a lot like the Pythagorean theorem in a way?
It does.
It's just that instead of using two sides, you have three. X, y, and z. Here's the thing, guys. The shortest distance between a box, or in a box, from one corner diagonally to the other corner, all you have to do is take each side of the box, square them, add them, and then take the square root. That's it. Alright guys, this problem. I want you to find the distance from point A to point C on this rectangular solid. It does want you to use the two-step development and do not use the formula. Well, guess what? I'm going to change it up. Use the formula first. We just built the formula. Use it so that we know what our end result hopefully should be. Okay, so what was the formula again?
X squared. BA.
So AC will equal the square root of
A squared.
x squared plus y squared plus z squared, where x, y, and z are the three sides. So square root of, what's one of the sides?
A.
The A is not one of your sides.
M.
M is one of your sides.
C.
Plus
C. 2.
2
3.
squared plus
3 squared.
3 squared, which equals square root m squared plus 4 plus 9, which equals the
36.
square root of m squared plus,
36.
no, not 36. You're adding
Oh.
13. We know the answer using the quick method should be the square root of m squared plus 13. Cool?
Yeah.
So now the question is, can we do that exact same thing? Because it's telling us to use the two-step method. If you go back to what we just did, we did this in 2 steps because we found the distance BC across the bottom before we ended up connecting the diagonal across from corner to corner. So you had to use Pythagorean theorem how many times for a 2-step process? 2. Can we do that though? Can you make that happen? Here's a cool thing. It doesn't matter if I'm using this right triangle on the right or if I use the right triangle on the left. They're both right triangles. So what we have here is that you should find that you have a right triangle with the base of 2, but if I call that a base of 2 here, what's this height? What is that height? What is the height, guys? Huh? It's 3 because 3 is here. You got other side is parallel to it, so it's 3. So if I use a squared plus b squared equals c squared, therefore c, if we want to call it c, or we can call that bc, we'll call it bc, because it is the distance from b to c, right? You would have 3 squared plus 2 squared equals, we'll call it bc squared, bc squared. That's 9 plus 4 equals bc squared. And what's 9 plus 4 again?
13.
13 equals bc squared, and take the square root. So that means this thing is equal to the square root of 13, which means I can put it here as, whoops, how did that happen? Square root of 13. So when I make my new triangle, what is the base of this triangle? What's the base of the triangle? Square root of 13. What's the height of the triangle? M, because M is from A to B. Can you find AC then?
Yes.
So A squared plus B squared equals C squared. So M squared plus square root of 13 squared equals AC. That's AC, sorry. Squared. What's M squared?
M squared.
M squared. What's the square root of 13? Squared.
13.
It's 13 equals AC squared. And then to get AC by itself,
Square root.
square root. So guess what? AC equals the square root of
M squared plus 13.
m squared plus 13. Booyah. They are the same. Two-step process versus the formula. You need to know how to do both. They were very nicely given to you. Break it up into two pieces, or to check your work by using the formula a squared plus b squared equals, or x squared plus y squared plus z squared with a square root over it. And your homework on lesson 5, page 47, day 5, 18, 19, 20, and 22. Have a fantastic day.